here we have our task on Patchwork. It says a sheet of square dot paper is provided for use with this item. I don't know if I provided that. It doesn't matter. So here's your question. Kate makes patchwork cushions using right triangles and squares. So these are cushions. She uses triangles along the edges of the cushions, and the rest is made from squares. The back of the cushions are made of a plain material, not patchwork. Here are the first 5 sizes of designs for it. So for size 1 for that cushion, how many right triangles are there? Well, they're all. And then how many squares? Well, you think there's one big square, but really that's 4 right triangles and no squares, even though the 4 right triangles do make a square on the outside. What's this pattern? On the edge, on the outside, how many right triangles are there? And then how many squares are there? So like 1, 2, 3, 4, 5, 6, 7, 8 right triangles and 4 squares. And then keep building that pattern and seeing that there's a pattern every time the bigger the cushion gets. So Kate makes cushions in many other different sizes. She begins to figure out how many triangles and squares she needs for each size. So like for size 1, we talked about it, we need 4 triangles and there's no squares. For size 2, she needs 8 triangles and 4 squares. So the first thing I want you to do is complete this table of value that's right here. So in size 1, we just said that there are 4 triangles and there are no squares. And in the second one, it was also given to you that there are 8 triangles and 4 squares. But I want us to fill out the rest of the table of values for the next size up. So size 3, size 4, size 5, that are all given in the prompt. So I need you to count for size 3. Can you count how many squares there are? And then I'll put down the number. And count how many triangles there are that make the edges. So first count the squares inside. Go ahead and do it. I'll do it and give you the answer. So the answer is, are you waiting for me? Is 12 squares inside. And then how many right triangles count? And if you're good, you can go, oh, that's 3, and then I can go times 4 for all of them, right? Because there's 4 sides. So I can see there's also 12 triangles that make it. All right, let's keep going. I want you to fill in this chart for the next size up. Size 4. How many squares and how many triangles? So obviously triangles are easy. I just go 1, 2, 3, 4, and then multiply it times 4. So that's 16. The squares, you're going to have to think. There's also a pattern here. You can do half and then double it if you like. But count the number of squares. So how many squares are on the left? There's 12, double it, that's 24 squares. One more to count. So again, the triangles, 1, 2, 3, 4, 5, then times 4. So that means there are 20 triangles. Squares, you could also do it in quarters, right? So if you can think of this as in symmetric quarters, you can count how many squares make up 1 quarter and then multiply it times 4. So in this case, if you count the number of squares in a quarter, there's 10 of them. And then if you multiply it times 4, that means there's 40. Some of you are so bright that you totally did that before I pointed that out. You found a quick way to add it up, and you weren't just like going 1, 2, 3, 4, 5, counting up to 40. Excellent. Number 1 stuff. Number 2, find a rule that will help Kate figure out the number of triangles she needs for cushions of different sizes. Explain how you figured it out. So in other words, if you have size 1, how many triangles do you need? Size 2, how many triangles do you need? So in this case, x is going to equal the number of, or the size number, sorry. And y is going to be the number of triangles. So what pattern, what algebraic equation could I write down? So if it was size 10 or 100, I could easily figure out how many triangles I needed. So 4 to 8 to 12 to 16 to 24, you can see there's an obvious linear relationship here in that it's increasing by how much every time? It's increasing by 4. So if I write down y equals 4x, if the size of the pillow is 1, how many triangles would you need? Well, 4 times 1, right? How about 5? If it's size 5, 4 times 5 would give you the number of triangles. So what equation could I use for that to figure out how many triangles I needed. So because it increases by a constant, and it's increasing constantly by 4 and it never changes, it's a linear because the increasing is constant, and we're done. Number 3 will be more challenging, but we're going to do it together. Number 3 is use the number of patterns to find a rule for how many squares you need. So for the number of squares, again, x is going to be the size number, and y is going to be the number of squares you need for that size number. So when I look at this table of values, I'm ignoring the middle column. For 1, I'd need no squares. Then 2, I need 4. And then 12, and then 24, and then 40. So part of the challenge is this increasing by a constant amount? So it increases by 4, then 8, then 12, then 16. It is not. So therefore, it is not linear. So what could it be? Let's look. Well, we're going to let Desmos help us out a little bit. So can you go to Desmos with me? So in Desmos, I'm going to do a table. So I'll give you a moment, or you can press pause. So for this table, I'm going to fill in the x values. 1, 2, 3, 4, 5. We're going to do a regression to help us. And if you've never done it before, here you go. And then I'm going to fill in the y values for the squares only. Try to double check, make sure I typed it in correctly. Notice my scale has already been shifted a bit, but if your scale is like this, right, then you know to zoom, zoom out until you see the picture. You can also scroll down. I need at least see up to 40, right? So when I look at this, if I could picture connecting the points together, what kind of function could that be where then I could have a rule to use that? So there's 2 that come to mind. One that comes to mind is exponential, and the other one that comes to mind is a parabola. Now, how would I know which one would better fit the data, and how would I do a regression to see, is there an equation that would go through all the points perfectly or close enough? So I'm going to teach you that right now. So we're going to do a generic exponential equation on Desmos and do a regression. And regression means you take the data and you come up with an equation that closely matches it, or maybe exactly matches it, but usually be real life, it would closely match it. Because then if you have a model that closely matches it, you can then predict the future with it, knowing that that model would stay consistent of what you're doing. This is very much in real world situation right now with what we're dealing with. All right, so y1 equals, so we have y1 and x1. So y1 equals, now what's a generic exponential look like? So there'll be an a in front. First of all, it's not equal, so go back. Because we're doing a regression, we need to use this button here. So I pressed the ABC button. Do you see the squiggly one right down here? So press that squiggly. That's similar. So this allows us that instead of equal sign to do something like, give me something close to what the points are. And then we'll look at it. So this is, think of it as a HK form for an exponential. So A is either going to be a stretch or compression, could be reflection. So I want to know what A is. We have a base, and then we have exponent on that base. So when I hit exponent, that's a to the b, I need parentheses because the whole thing won't stay in the exponent without parentheses. And then I'm going to go x1 subtract h and then close the parentheses. Now that x1 subtract h is that hk form of an exponential. I'm going to move the cursor and then I'm going to put down plus k so you can see the hk form of an exponential. Now, a few things I'm looking at here. It gives me an a value for those data points. First of all, if I look actually at the line itself, I can tell that, man, they go right through those points very closely. So it isn't a bad model at all. This model feels like it goes through most of the points that we're talking about. So I like this model to begin with because I see the line that it created and it goes through the points that I see. What else am I looking at here? So do you see this r squared? Maybe if you're in stats, you've talked a bit about it. I'm going to make it really simple. If r squared equaled 1, it would be a perfect match. Any number that's very close to 1 is a very close match and is a good model. So 0.991 is a very good model because it's super close to 1. Now, I'm not going to stop there, but I'm just showing you that's a good model because the number is close to positive 1. Any number close. If it's exactly 1, it's an exact match. All right, so if I use this model, I would use an equation where A is 8.4728, H is that, K is that, B is that, and so on. I'd plug in those values for A, B, H, and K, and then write my equation saying, okay, I have an equation, a model that tells me how many squares to use. Part of the challenge with this model, of course, is that I can't have 1.48 whatever squares. So the answers I need to come up with have to be whole numbers. In this model, I'd have to round to figure out how many squares I need. And for this pattern, I don't think this rounding part is going to necessarily be the exact one I'm looking for. So I'm going to do another model. Remember I said it kind of looks like an exponential? And it does. It could match very similar. How about a quadratic? Could a parabola be even better? So we're going to do that right now. So I'm going to go y1. And again, I'm going to get that squiggly line. Where is it? There it is. And again, it's HK form with an A in front. So A, x1 subtract h, square it. So this is the HK form of a parabola, plus k. And then I want to look at, okay, what happens if I do that? So I'm going to take this one off so you don't see it. So now you only see the red. And again, if I look at the red, and I think if I can even go like from 0. No, I didn't even worry about it. I was trying to create a domain restriction here so you could see it. But obviously ignore the parabola to the left because anything to the left is not what we're looking for. So even if I go here, if I could just change my x-axis and change it to 0, and then if I change it from 0, and this we only have to 5, right? So we can change it 0 to 5. If I look at 0 to 5, and also here the y values would go, 0 to, what is it, 40 or 50. When I look at it, does it go through all the points that I'm looking at? So at 1, at 2, at 3, is it exactly through the points? It looks very good. And why is it a better model than what I just did? And what's the indicator? See here for stats again, r squared, what is it equal to? And r squared is equal to 1. 1 means it's a perfect match. 0.991 means it's a very close match. So which one do I want? I want the perfect match that then would give me the whole numbers that I am looking for. So what equation then would I write down for number 3 that would match it? So I'm going to write down y equals A, it says is 2. And then I'm going to go x subtract 0.5 squared subtract 0.5. So let me go back to here so you can see that. So I got what A, H, and K equal. And now I want to know that this matches this. So in other words, if I plug in 1, if I go 1 take away 0.5, that's a half, squared, that's a quarter, 2 times a quarter is a half take away half. Like, does it actually fit what I'm looking for? So to just double check to make sure this equation is a good equation, what I'm looking for, I'm going to go back to Desmos. I'm going to type it in. I'm going to type it in as a function. So I'm going to go f at x equals, and I'm going to type in what I just came up with, which is 2x subtract 0.5 squared subtract 0.5. And I want to know if that works. So first of all, you can see it totally goes through the points, but this is what I'm looking for. If I do another table, and I call this x, and I call this just y, it will match that. So for size 1, what should the answer be? Is it going to give it to me? No, not going to give it to me with the table. Okay, so if I plug in, let me erase the table. if I plug in 1, size 1, the answer better be 0. If I do size 2, the answer should be 4. If I do size 3, it's 12. If I do size 4, it's 24. Size 5, 40. So it exactly matches the table of value, and I use technology to help me find a model that fits it exactly. This is where our world is going to. All right, let's go back. So here we are. We found a rule, and then we obviously know our rule works as we test it out with Desmos. So next one, last question here, number 4. It says Kate has a cushion made with 180 squares. How many triangles are in this cushion? Now, we don't have a rule that has squares and triangles, so I have to start with one information and work backwards. So we have our equation y equals this, and y is the number of squares. So we're told the number of squares is 180. That is the equation I need to solve for and see what x equals. Doesn't seem that much fun, but we're going to go to Desmos to solve it. So how do I solve this with Desmos again? So let's go to Desmos. I'm going to erase this, what we have. I'm going to keep that one on there. So notice I'm going to keep this one on there, which is the equation, but I need one more. I need to know what it equals when it equals 180. So I'm going to type in y equals 180. So I have my equation that I came up with, but the second equation in the second box is 180. And then how do I solve this? Is I'm going to zoom out until I see the two lines meet. So I see them there, the green and the blue. And so what answer do you get for that? So I get x to equal 10 when y is 180. So I'm going to come back. So I got x is equal to 10. So I know what now? The size number of the cushion is size number 10. So now I'm going to go back to this equation. How many triangles are there? Well, if the size of the cushion is 10, then how many triangles do I need? So I plug in 10, and you need how many triangles? So you need 40 triangles with 180 squares. And it's done. Good job doing the task and working with me on Desmos. Mr. G Math over and out. I'm proud of you, and until next time.